Here we're going to look at some homework questions from section 7.2, where we're continuing to talk about confidence intervals, but we're going to look at them dealing with the mean. So for this one, it was number 27 on your homework. It said assume that we want to construct a confidence interval, and we're going to figure out if we want to use a critical value based on the t distribution, the z distribution, or state that we can use neither. So remember, to be able to use z or t distributions, we need to fit one of these categories. We need to have a population that's normally distributed, or we need to have an n that's greater than 30. So if we look at this, they tell us the confidence level is 95%, our population standard deviation sigma is not known, and the histogram of 63 player salaries in thousands of dollars is shown. So if we look over here at this histogram, it's definitely not normal, right? If I tried to draw that bell curve, it does not fit it. So we can't use that requirement. However, if we look at our sample size, it's 63 and is greater than 30. So that means we can use either our z distribution or our t distribution. So we need to figure out which one to use. We use our z distribution all the time for proportions. And then we also use z for our mean if our population standard deviation is known. We use t for our mean if our standard deviation of the population is not known. So we know they're talking about the mean because they're talking about a standard deviation in here, and they tell us that it's not known. So for that to be the case, that means we need to use our t distribution. So that means with our options A, B, or C, we're going to use option A to find our t critical value, our t of alpha over 2. So there's two ways to do this. We can use our table that's given to you in your formula sheet, or you can use your calculator. If you're trying to use the table, the first thing you need to do is calculate the degrees of freedom. And remember, your degrees of freedom is n, your sample size, minus 1. So our n was 63. If we subtract 1, we find that our degrees of freedom is 62. So then you go to the table, you look for your degrees of freedom equal to 62, and then if we try to figure out what's going on with alpha, they told us that confidence level was 95. So remember, that's 0.95, and our alpha is 1 minus our confidence level. So our alpha is 0.05. Every time that we're doing a confidence interval and we're looking at the table, we want the area in two tails. So if we go to our table, there is a slight issue. When we get down into those higher degrees of freedom, they're only to the nearest 10. So if we have to choose between 60 and 70, we're going to really look at our degrees of freedom of 60. And then we're going to go over to the third column. We're going to go area in two tails, and then look at that 0.05 for our alpha level. If we go there, that's going to give us 2.000. So that's our critical value, our t alpha over 2. Now you can also use your calculator. If you want to use your calculator to do this, I posted a video that'll walk you through how to do it. You're going to use your t interval test. So you're going to hit stat and then scroll right to tests, just like we did before. And this time you're going to choose option 8, which was t interval. When you do that, it's going to prompt you to choose data or stats. You do want to use stats. You'll use data if they give you a list of data. When you're trying to find the critical value, you're always going to set your x bar equal to 0, and you're going to set your sample standard deviation equal to the square root of n. which would be the square root of 63. When you do that and hit enter, it will calculate it out to the next screen. When they ask you for your n, you type in your actual n, so that's 63, and then the sea level, you actually use that sea level in decimal form, so that 0.95. When you do that, it's going to give you a confidence interval. So in this case, it gives us negative 1.999 and positive 1.999. Remember, whenever we're talking about a critical value, whether it's in the t or the z distribution, we always pick the positive one. So here we do have slightly different answers with technology and the table. MyLabs Plus is programmed to take both. And if I remember correctly, I think this problem on the homework asks you to round to the nearest hundredth, 2 decimal places. And if we do that, we'll get the same answer either way. Because here, that 0 tells us to leave it alone. Here, that 9 tells us bump that 9 up. And then we kind of get that waterfall effect where we keep bumping over until we get that same critical value either way. Now that we know how to figure that out, we can look at how to actually find a confidence interval. So if we look at number 31, a clinical trial was conducted to test the effectiveness of a drug for treating insomnia in older subjects. Before treatment, 21 subjects had a mean wake-up time of 105 minutes. After treatment, the 21 subjects had a mean wake-up time of 84.6 minutes and a standard deviation of 21.7 minutes. Assume that the 21 sample values appear to be from a normally distributed population and construct a 95% confidence interval estimate of the mean wake-up time for a population with drug treatments. What does the result suggest about the mean wake-up time of 105 minutes before the treatment, and does the drug appear to be effective? So at first glance, this is a rather long question. So I'm going to look towards the bottom and see what they're actually asking me to do. So they're telling me that I'm going to construct a 95% confidence interval estimate of the mean wake-up times for a population with drug treatments. So if I'm looking for everything with the drug treatment, they're telling me that I have my 21 subjects, so that's going to be my sample size. They had a mean wake-up time of 84.6 minutes. Now notice this is a sample, so that's my X bar, not my population mean. And a standard deviation, so that's my sample standard deviation. So if I'm trying to figure out my confidence interval, I know that I'm calculating it for the mean. So I need to decide, am I going to use my z-test or my t-test? Now, notice my n is small, it's less than 30, but they do tell me that they appear to be from a normally distributed population. So it's okay to use z or t. Because I don't know the population standard deviation, I only know the standard deviation of the sample, I need to use my t distribution. So now that I figured out which distribution to use, I can decide to do it by hand or to use my calculator. I'm going to use my calculator because it tends to be faster. So I'm going to hit my stat, tests, and then I'm still going to choose option 8, that t interval. If I knew my sigma, I would choose option 7, the z interval. When I do that, they ask me for my sample mean, which is 84.6. They ask me for my sample standard deviation, which is 21.7. They ask me for my sample size, which is 21. And they ask me for my confidence level. If we look back up, we needed a 95% confidence interval, so that confidence level is 0.95. When I hit enter, that gives me 74.722. and 94.478. This problem in the homework asked me to round to 1 decimal place. So if I was typing this in, I would say that my confidence interval goes from 74.7 minutes, which is less than my population mean, which is less than 94.5 minutes. Remember, our confidence interval is always an estimate of that population parameter. So they're asking us, what does the result suggest about the mean wake-up time of 105 minutes before the treatment, and does the drug appear to be effective? So if we think about this 105, that's not in our confidence interval. So we can say the confidence interval does not contain the mean wake-up time of 105.0 minutes before treatment. So that means, this result means or suggests that the drug does have a significant effect. If that confidence interval contained that 105, then we'd say it does not have a significant effect because the mean could be in there, but it's definitely not. That mean from before, that 105, is above this confidence interval. It's not anywhere in there. So we know with 95% confidence that there is a significant effect.